Right. The topic of the day is Overlay Transport Virtualization, OTV. Overlay Transport Virtualization. What it is? It is another tunneling concept. Another one of the tunneling concept. Overlay concepts. There are various virtualization concepts we see. This is another virtualization. Tunnel is a virtualization, right? A virtual circuit. So this is another virtualization concept. If you see here, there are LAN switches at the bottom. They're connected to Nexus 7000 series. And this Nexus 7000 series, they are not in one single location. This is different geographical location. And this OTV helps us to have a common LAN. This is what OTV is. What does OTV provides? It provides an extended layer 2 domain. Even though this is in Dubai and this is in Perth, Australia, somewhere. Though it's too far geographically, the VLAN 10 member here, who belong to VLAN 10, can ping to someone here who is also in VLAN 10. You know, the LAN you see, it's extended. Physically not, virtually. These connections are virtual. Looks like ACA fabric, no? Leaf and spine architecture. You know, this is what we achieve through OTV. But in reality, it is not like this. There's a big separation here. And this switch belongs to Perth. This switch belongs to Dubai. But we can now communicate between this device as if these devices are in same local area network. How is that possible? Through this tunnel, OTV tunnel, Overlay Transport Virtualization. What is needed is an IP connectivity between the data center. That's the important, fundamental or basic building block. All that I need is a ping, a reachability between this interface, this port and this port. If I'll ping between these two devices, that's enough for Nexus 7000 to provide you this OTV. So this feature is available only in Nexus 7000 series, not in 5000 series. See, after this, they got a different, it was an eye-opener for Cisco. From this small idea, a lot of big ideas have now born, like SD-WAN, WebTrail and so on. So this is the beginning. This is where they begin.
Okay, sir, this is the same case of VXLAN, right?
Yeah, you see, almost same, no, but not the same. That's totally different. See, in VXLAN, we do between the routers within the same data center. But you see here, this is different data center, different geographical location. And VXLAN is layer 2. Even if you do VXLAN across the geographical location, it's going to be a layer 2. But this OTV Though it's layer 2, it can extend multiple VLANs. Anyway, see, do not bring VXLAN here because you got VNIs in VXLAN. In OTV you don't have such things, so cannot compare this and that. This is different, that is different. I can say this is what gave idea to come up with a concept called VXLAN, ACI, SD-WAN, and so on. This is the key, or this is the real source from where they got the idea and they made it bigger. So what is the basic requirement? We need IP connectivity between the data centers. This is between data center. How it works and all we will see later. Now, the only requirement for the transport infrastructure is to provide IP connectivity between the data center. So for OTV does not extend spanning tree. Very nice point that we should remember. OTV will not extend spanning tree. Even though layer 2 extended, even though the layer 2 VLANs are extended, the STP is local. You will have your own root switch here, you will have your own root switch here. No BPDUs are allowed to pass through. No BPDUs. So, though VLANs are extended using OTV, that is what OTV does. The OTV does what? It extends VLAN from one data center to another data center, so that members of this data center will ping as if they ping the remote data center as if they ping the members of the same data center, which is easy for a lot of virtualization concepts like vMotion and so on. You know, for many virtualization features, you should not have routing. Routing should not be there for various virtualization features. One of the features is vMotion. So you need only a layer 2 in between. But when you have internet in the middle, in order to have layer 2, you may need a layer 2 VPN like VPLS and HVPLS and so on, which is like service provider dependent. OTV, no service provider dependency. Service provider just provides you the IP reachability, that's all. You can ping from this end of the world to the other end of the world. You can ping. With that, you can have this layer 2 extension. So OTV does not extend spanning tree across the site. This is one important point to be noted. It also provides other benefits like ARP caching, meaning you are not going to flood. If this device sends an ARP request, this will respond. Actually, it is sending an ARP request to this computer B. But this knows the location of B, this knows the MAC address of B, it will respond back. Proxy. So you don't need to flood, you don't need to flood through the tunnel, OTV tunnel for ARP. So ARP caching is there, so you can use that caching. Multicast optimization, so you're not going to flood to everyone. We will use, if you are using OTV with multicasting. See, OTV can be with unicast, which is statically configuring the OTV remote peer, or you can use multicast to discover the remote peer. So multicast spats mode you need to have, or you need to have bidirectional PM, which is supported by OTV. So the points to be remembered here is no spanning tree across the tunnel, over the tunnel, across the site. ARP packets are not flooded over the OTV tunnel because there is no need for flooding. because every every OTV edge device will know the remote device MAC address. Maybe this is the point that might have made you to think like, oh, it's same like VXLAN. I agree. VXLAN, with the help of EVPN, we learned the MAC address and the IP address of the remote leaf. The control plane is built, agreed. But here we don't use BGP. We don't use BGP here. BGP is not a control plane. Here we use ISIS. And you don't enable ISIS. ISIS gets enabled automatically. When you enable OTV, ISIS gets enabled. So you don't need to have a knowledge of ISIS to enable this feature OTV. Next, OTV provides an overlay that enables layer 2 connectivity between separate switches, switch domain, keeping these domains independent and preserve the fault isolation, resilience, and load balancing. Excellent. You see, we got two separate layer 2 domains. What is the advantage? If the layer 2 domain here has gone wrong, it will not impact the layer 2 domain on the remote. We are simply extending the VLAN, but if something goes wrong with here, it won't impact the other because we don't have a common BPD or common STP. STP is local and we use ARP cache for ARP. So everything is localized, so there is no problem. If one data center goes bad, it's not going to impact the other data center. And you can have, if you have multiple connections to your remote site, you can have load sharing, load balancing, all those features. See, the cloud may be an IP or MPLS or anything, that doesn't matter. All that we need is a reachability between this interface, this port to this port, that's all. You may be reaching via MPLS or segment routing or IP, whatever. That doesn't matter. So what you're going to transport, you're going to transport the layer 2 by encapsulating with layer 3 address. So we can call it as MAC in IP. MAC in IP. This concept is called as MAC in IP. Layer 2 on top of layer 3. So Cisco OTV, the modern data center must meet different requirements for speed and flexibility to accelerate application deployments and fulfill the operational need. So a layer 2 extension, what we expect. Extended layer 2 connectivity between data center is needed to enable server clustering across the data center and cloud integration. That's what I mean, vMotion, one example for cloud clustering, server clustering in the cloud. And OTV provides a layer 2 extension capability over the transport infrastructure. So that the transport infrastructure may be another layer 2, or it can, means when I say another layer 2, it may be VPLS tunnel, it may be a MPBGP tunnel, or it may be MPLS, and so on. OTV provides fault isolation, resilience, load balancing, as well as ARP caching and multicast optimization, which we already saw. I'm sorry. So what are the characteristics of OTV? MAC routing. Alright, so the control plane, the control plane used to exchange MAC reachability information. So OTV exchanges, distributes, advertises the MAC reachability. So there is no need for data plane flooding, no need for multicast based flooding or data plane flooding. Or not like a traditional switch flood and learn. It's control plane, means ISIS is the control plane here, which is going to carry the MAC address of the remote side down to here and the MAC address of the downside to the remote data center edge. So layer 2 frame is carried inside layer 3 packet. For that you don't need MPLS or any pseudo wire. OTV can do this. It simply takes the layer 2 frame, encapsulates layer 3 and go to the remote site, deliver to the remote site and decapsulate it, get the layer 2 frame again, deliver to the layer 2 domain. That's how layer 2 extension happens.
Okay. Do we have a header all this one?
Come again? Yeah, header will be added.
Do we have a header?
We'll talk about the headers that are added. Yes.
Okay.
Of course, the headers are going to be added. So native multi-homing, meaning if you want to have redundant edge device, you can have redundant edge device. You can have multiple ISPs. You can connect to more than one ISP. Have load sharing. There is no need of STP because it's layer 3. Layer 3 is used as an underlay. Even though you have multi-homing, you still have redundant path because it's going to be layer 3 loop-free network on top of which the layer 2 frames are going to be carried. So according to the service provider, they don't see your layer 2 packet, they just carry the layer 3 packet inside which layer 2 is encapsulated. And we also spoke about ARP caching that helps to find out the remote sites. Now this is what I was talking about. Look at this. We have a layer 2 VLAN 10 computer here, and we have a layer 2 VLAN 10 computer here. A and B is going to communicate, and layer VPN 10 is extended down here. A and B speaks as if they are in same local area network. Usually when you do routing here, what will happen is when B receives the packet, you will not be receiving the packet from the source MAC address A. You will be receiving the packet from the MAC address of this gateway. Agreed or not?
Yes.
Yeah, when we do routing, our source address will be the MAC address of our gateway. So B receives with the MAC address, let's say C. But in this case, when B receives the packet, it receives the packet from the source A. Likewise, when A receives the packet, it receives the packet from source B. Which I just said this make you understand what the layer 2 extension means. Though you understood it, I just made it more clear. So VLAN is extended. So the layer 3 is totally hidden. Right? The encapsulation hides the layer 3 domain. So you see, now this clearly explains you. This is the exact picture what you had in the very first main page. This is what here means. VLAN 10 is extended because of the OTV tunnel. Right, so OTV uses the MAC routing.